Hello friends, I am Professor Nisar Ahmed Khan from Department of Economics, Aligarh Muslim University. Today I'll talk about time value of money. Now the value of money keep on changing with time. Even a layman knows that 100 rupees today and 100 rupees after 1 year or after 6 months or after 10 days are not same. The value of 100 rupees after 1 year will be different as compared to value of 100 rupees now. Now, how this money grows? In finance, the money grows at the rate of interest. So first we will talk about the future value, that how a present value grows and becomes a future value and how to calculate the future value. And then we will talk about from the future value how can we obtain the present value, that is the calculation of present value. So let's say first how do we obtain the future value. Now it depends that whether the rate of interest is a simple rate of interest or rate of interest is a compound rate of interest. So let us say that we have Pt is the amount that you will get after T period. P0 is the amount that we deposit, that is initial deposit, that is we call also as principal amount. R is the rate of interest, T is the time. If we have a simple rate of interest, suppose we have simple rate of interest, in the case of simple rate of interest, we know that suppose the amount that you will get after 1 year will be P0, that is the principal amount, plus the interest. Interest will be P0 multiplied by R. This is the amount that you will get after 1 year, that is P0 1 plus R. Now this amount we will continue to get every year, that is this interest amount will be same in the case of simple rate of interest. Every year we will get the same interest amount because this interest will not be added in the principal amount and consequently the principal amount will remain same for all the years in the case of simple rate of interest and therefore the interest income here will be same. For example, if suppose P0 is rupees 100 and R is 5% and suppose T is equal to 2. So we see the amount P2 will be equal to 100 plus 100 multiplied by 5% and this is for 2 years. So you multiply it by 2. So therefore it will be equal to 100 plus that is 10. So P2 will be 110. So every year the interest income will be rupees 5 because the principal amount is 100. So every year the interest income will be rupees 5. That is, if you say deposit is for 1 year, you will get after 1 year 105. If you deposit for 2 years, you will get 110. If you deposit for 3 years, you will get 115. So therefore here we see the formula is very simple that Pt is equal to P0 1 plus R multiplied by T. This is how we calculate simple rate of interest. But simple rate of interest are practically not used. What we see that in most of the cases we find there are compound interest rate is being used. So how can we get the future value in case of compound rate of interest? So here we have at the end of, let us take an example and from that example we will tell you how to calculate compound future value using compound interest rate, that is value of deposit. So 1 year, at the end of 1 year, at the end of 1 year, you see P1 will be, if P0 is the principal amount, R is the rate of interest, T is the time period, and PT is the amount that you will get after T period. So P1 will be equal to P0 plus P0 multiplied by R. And we can simplify it, P0 1 plus R. This is the amount that you will receive at the end of 1 year. This is the interest income and this is the principal amount. So you add both and you will get P0 1 plus R amount after 1 year. So after 2 years, we have P2. Now in the second year, the principal amount, because now we are talking about compound interest rate, let us write it here, compound interest rate. Compound interest rate is not simple rate of interest, it is compound rate of interest. So in the second year, the principal amount will be the amount, total amount after first year. The total amount after first year is P1. This will serve as principal amount and interest will be calculated on this amount. So P1, 1 plus R. Now, if you substitute the value of P1 here, because P1 is equal to P0, 1 plus R, if you substitute the value of P1 here, that is P0, 1 plus R, then it will become P0, 1 plus R raised to power 2. Similarly, the third year, after 3 years, or after third year. In the third year, that is the amount that you will receive after the 3 year or the third year. Now in the third year, the amount after the second year will serve as the principal amount. The amount after second year is P2. That will be the principal amount on which interest will be calculated. So it will be P2 1 plus R. Now if you substitute the value of P2 here, P2 is equal to P0 1 plus R raised to the power 2. If you substitute the value of P2 here, this will become P0 1 plus R raised to power 3. Similarly, after 4 years, that is P4. In the fourth year, you know, the amount after the third year will become the principal amount, that is P3, and interest will be calculated on that, and it will be this. Now, if you substitute the P3, which is equal to P0 1 plus R raised to the power 3, then it will be equal to P0 1 plus R raised to the power 4. So now it's enough. We can go and we say after T years. After T years, that is we have here PT. After T years, that is PT. So PT, after T years, that is PT, PT will be equal to, you know, in the fourth year it is P0 1 plus R raised to the power 4. In the third year it is P0 1 plus R raised to the power 3. In the second year it is P0 1 plus R raised to the power 2. By that analogy, after T year, it will be P0 1 plus R raised to the power T. This is the amount that you will receive after T period. If you deposit P0 amount as principal amount in the beginning, and the rate of interest is R and time period is T, the amount received will be this much. Now this is the formula of compound interest rate. That is, the formula of compound interest rate is PT is equal to P0 1 plus R raised to the power T. Meaning thereby that if you deposit P0 amount and the rate of interest is R and the time for which you deposit this money is T, then after T period you will receive this much amount. This is this is based on the compound interest rate. That one was based on simple rate of interest, where the interest income will be same every year. But in the case of compound interest rate, interest income will not be same every year. It will be different for different year, because the principal amount is going to be different for different years. Now in case, suppose the compounding, this will be the case when the compounding is taking place annually. If suppose compounding is taking place half yearly, that is, interest is calculated 2 times in a year. If interest is calculated 2 times in a year, that is 6 monthly, after 6 months interest will be calculated, and then interest income will be added in the principal amount, and then interest will be calculated for the next 6 months. If interest is compounded 2 times in a year, that is 6 monthly, then we will divide it by 2, because the R is the interest rate for the year. And here we are calculating interest for 6 months. So it will, the interest for 6 months will be R divided by 2. And the time, it will not be 1 year, but now it is 6 monthly interest is calculated. So this will become as 2T. If we calculate interest, suppose if we calculate interest, say quarterly, that is, quarterly means 4 times in a year, then this formula will become P0 1 plus R raised divided by 4, 4 multiplied by T, that is 40. This will be the amount that you will receive after T period if interest is compounded 4 times in a year, that is quarterly. If interest is compounded monthly, then this will be P0 1 plus R divided by 12, and this 12T. If interest is compounded m time in a year, so then the general formula will be Pt will be equal to P0 1 plus R divided by m multiplied by T, that is Mt. So this will be the amount that you will receive after T period if interest is compounded m time in a year. Now, if interest is compounded, say continuously, every second interest is compounded. If every second interest is compounded, m will become larger and larger. Then what will be the value of T in that case? We can also calculate that. So, we said that the amount received after T period when interest is compounded m times in a year, this will be equal to Mt. But imagine a situation in which interest is compounded every second, every moment, continuously interest is compounded. And if this is so, then m will become larger and larger. Then in that situation, what will be the value of Pt? So Pt will be equal to P0, we can write it as P0 1 plus R m and then T. We can write in this way. And this is divided by m. Yes. So Pt is equal to P0 in the bracket, and then small bracket 1 plus R divided by m raised to power m, then bracket close, and it is raised to power T. Now, we can, if suppose m gets larger and larger, and m will get larger because the compounding, m means the number of times in a year compounding is done. And if compounding is done continuously, every second compounding is done, then every moment compounding is done. That is what we call as continuous compounding. Then m will get larger and larger. And in that situation, 1 plus r divided by m raised to the power m, this will tend to e raised to the power r, er. This will become this. And it means that then pt will become equal to e raised to the power r t. This is how the amount will be calculated, future amount will be calculated when compounding is done continuously, that is every moment, every second compounding is done, and consequently the number of times in a year compounding is done is going to be almost infinite, very large. So this will be the value of PT when there is a continuous compounding. Now, this is how we can calculate the future value. If the P0 amount is deposited, then how much amount we will receive after T period, that can be calculated using this formula of compound interest rate. Now, if we have annuity, then how can we calculate? So, we talked about how to find out the future value of an initial deposit. The money is deposited only once and it grows at compound rate of interest, and in future we have to calculate its value, and that we told you. Now we'll talk you about how to calculate the future value of annuity. What is an annuity? An annuity is deposits or withdrawal of equal amount at equal interval. You may also define an annuity as a flow of, or you can say a cash flow of equal amount at equal interval. That can also be called as annuity. So an annuity, there are two conditions, for an annuity to be satisfied. The first is that all the deposits or all the withdrawals or all the income or all the cash flows should be of equal amount. The second condition is the gap between the two deposits or two withdrawal or two income or two payments should be same. It should not change. So, how to work out the sum of an annuity? Let us take an example. Suppose we deposit equal amount at equal interval for 4 years. So we have, let me write here annuity first. So let us say the amount is like this, that is, this is the year, that is the 0, 1 first year, second year, third year, and 4th year. So we will deposit the money or we will deposit the amount at the end of the year. That is, at the end of the first year, I'll deposit 100 rupees. At the end of the second year, again I'll deposit 100 rupees. And at the end of third year, I'll also deposit 100 rupees. And at the end of fourth year, the last year, we will deposit also rupees 100. So we are depositing the money at the end of each year, and the money is being deposited for 4 years. So there are 4 annuities, the first, second, third, and fourth. Now the important thing is that here, when we are depositing money at the end of the first year, during this period, we will not get any interest. And when we are depositing money at the last, in the last year, that is rupees 100, then on this money also we will not get any interest. So the interest that we will get, that is this money that we deposited at the end of the first year, now on this money we will get interest for 3 years, that is this, and this for 3 years. And this money that we deposited at the end of the second year will get interest for 2 years. And this money that we deposited at the end of the third year, we will get interest for only 1 year. And this money that we have deposited in the last year, that is the fourth year, on this money will not get any interest, because so we have to find out what will be the total value at the end of 4 years. What will be the total value of our deposit at the end of 4 years? So we can find this is an example of an annuity, because we are having equal deposits here at equal interest, equal interval. So let us find the sum of this annuity. We write it as 3, as 4, because the annuity, there are 4 annuities, that is 4 years are there. So we have written 4. On this amount, 100, 1 plus R, that is the formula that we told you for single deposit, that is one deposit in the initial deposit on which we find out the future value of which, and on which the rate of interest rather is compounded, a compounding rate of interest. So we'll get for 3 years, so we'll write it 3, because on this deposit we will get the interest for 3 years. Then on the deposit, this deposit, we will get interest for 2 years. R here is the rate of interest that we have already told you. And then on this one, we will get interest for only 1 year. And this one, the last one, will not get any interest. So let me remove this one so that there is no confusion, because this is being extended. So we'll remove this. And so the fourth year, the money that you will receive at the fourth year, it will be same. There will be no change in that, because you will not get any interest on that. So this is the sum of the 4 annuities that we have received over these 4 years. That is, this is the amount that you will get, this amount, 100 rupees, we will get interest for 3 years. This amount we will get interest for 2 years. This one we will get only for 1 year. On this we will not get any interest. So this is it. Now one thing you notice, that we have deposited, money, or we have deposited the amount for 4 years, but what is the maximum, the amount on which we are getting the interest for a longer period is 3 only. 4 is 3. So by that analogy, if suppose we generalize generalize this method of finding the sum of an annuity, suppose we take the annuity we get for n years, and the amount that we deposit at the end of every year is A. So A is the amount that we are going to deposit at the end of every year, and the number of years are n. So we can find the sum of the annuity as Sn we can write. Now here, when we are depositing for n year, here we deposited for 4 years, so here it is 3. So in the case of this, when we are depositing for n year, it will be n minus 1. So we'll start with this, that is, here we have A amount is being deposited, so we'll write A 1 plus R n minus 1 plus A 1 plus R n minus 2 plus A 1 plus R n minus 3 plus A 1 plus R n minus 4. And likewise we have the last one will be A 1 plus R. This will be the item just before the last item, and we will have at the end A, because the money that we will deposit in the nth year, that is the last year, will not get any interest on that, so that is A. So this is Sn, or sum of an annuity for n years, where an equal amount is deposited at the end of each year. Now remember, the amount is deposited at the end of each year. The amount is not deposited in the beginning of the year, rather the amount is deposited at the end of each year. So the A amount is deposited at the end of each year. So this amount is equal for all the years. This amount will be equal. You see, this amount deposited is same, and this amount is deposited for n years. So in the nth year, the last year, no interest will be obtained. Whereas here, the first amount that you will deposit at the end of the first year. So therefore, the interest that you will receive on this amount will be n minus 1. Just like here we have 4 minus 1, you can say, and we have 3. So now we can have some manipulation here so that we can obtain the sum of this annuity. And for this, we are going to remove this all so that we can find out the sum of the annuity. Now in this case of finding the sum of the annuity, that is what we do, that whether it is deposit or it is withdrawal or it is a cash flow, it doesn't matter. The technique will be same. The technique of finding the sum will be same. There will be no change in that. Whatever may be the case, whether we are withdrawing equal amount or we are depositing equal amount, there will be no change at all. So let us now also remove this. So we'll have a fresh one that will be easier and less confusing.